Okay, let's unpack this. Imagine a theory that literally redefines everything you thought you knew about reality. I mean, from why things have mass to why dimensions even exist. That's exactly what we're diving into today. We're exploring the unified coherence theory of everything, the UCTE by Philip Randolph Lillian, hot off the presses, July 2025. And this isn't just another physics paper, you know. It's this really audacious attempt to lay out a complete picture of everything.
Right. And our mission today is, well, it's quite special. We've got this unique stack of detailed addenda. These are the deeper dives into the UCTE's mechanics, almost like finding the hidden blueprints, you know. Our goal is really to pull out the most groundbreaking concepts, the surprising aha moments from these appendices. We'll explore how these deeper insights fundamentally reshape our understanding of mass, gravity, quantum resonance, maybe even consciousness itself.
So settle in. We're about to take a pretty fascinating journey through these foundational documents. And our promise is to try and make even the densest concepts accessible and intriguing. You'll hopefully walk away from this deep dive with a truly unique perspective on reality's deepest mechanics. Let's start with a radical reframe, right from Appendix C.4. Forget what you thought about mass coming from the Higgs field. In UCTE, mass apparently arises from something called coherence condensation. What exactly is coherence condensation?
Yeah, that's a great question, and it's a huge shift. Imagine the universe isn't just empty space, right? But it's this vibrant, invisible ocean of energy, the omnilectic vacuum. Now think of hypergravity as a kind of invariant foundational current within that ocean. Coherence condensation is when field structures essentially lock into step or phase lock with this hypergravity current. They form these stable, persistent patterns.
Right.
So mass, then, isn't something intrinsic to a particle. It's the result of this stable, phase-locked pattern. And what we call inertia, you know, that resistance to change in motion. It isn't just about moving something heavy. It's the resistance to this stable pattern breaking apart, to decohering.
Ah, okay. So mass is less like a solid thing and more like a stable whirlpool in this cosmic ocean. And inertia is the whirlpool trying to stay a whirlpool. That's genuinely a new way to visualize it. And the famous Higgs boson, where does that fit in?
Exactly. The Higgs boson in this framework, it isn't the source of mass. Instead, it's reinterpreted as an emergent scalar resonance mode, basically.
Right.
A specific vibration or ripple that appears because of this coherence condensation, not causing it. It's more like a symptom, not the cause.
Wow. That reframing of mass alone is huge. And it leads us right into how UCTE redefines dark matter, doesn't it?
Okay.
Appendix C.4 again. This is not some exotic, undiscovered particle.
That's right. The UCTE suggests dark matter isn't a new kind of particle, but rather hypergravity coherence residues. Think of them as these stable, weakly interactive structures that are so perfectly aligned with hypergravity. They just don't really project into our observable, more decoherent space or like perfect camouflage. Not because they're invisible exactly, but because they're operating on a different fundamental level of coherence. They exist, they have gravitational effects, sure, but they don't interact with our conventional light or forces in the usual way.
So dark matter isn't missing matter. It's coherence we just can't see because it's so perfectly aligned with this hypergravity. That's a profound shift. And it doesn't stop there with fundamental forces, does it? Appendix C.13 radically redefines gravity itself. It's not space-time curvature.
No, not in UCTE. Gravity gets redefined as a recursive coherence anchoring process. This is a bit like the universe's internal glue, you could say. It's the continuous self-reinforcing process where field structures bind together through something called tensor resonance. Imagine the universe isn't a flat sheet bending, but maybe a symphony of interconnected vibrations. Gravity is the ongoing rhythmic process that keeps all those vibrations in tune, holding them in place. It's really the persistence of coherence.
So gravity isn't pulling you down. It's more like the universe actively resonating, keeping everything connected and stable. That's a very different picture. And what about symmetry breaking? We hear that a lot in particle physics. Appendix C.8 suggests it's not some spontaneous external event.
Precisely. UCTE reframes symmetry breaking, not as something happening to the system from outside, but as a torsional phase misalignment within the coherence field itself. Think of it like a perfectly balanced spinning top. If there's a slight twist or torsion within its internal structure as it interacts with those hypergravity gradients, it can appear to wobble or break its symmetry. But the symmetry isn't truly gone, it's just coherently redirected through topological torsion. It's an internal rearrangement, not an external disruption.
So symmetry isn't broken, it's just rechanneled. And this leads us to supersymmetry in C.9. Instead of undiscovered partner particles, UCTE has a different idea.
Yes. UCTE says supersymmetry isn't about finding these undiscovered superpartners. Instead, it's a duality within the torsion structure of the coherence field. It means every stable eigenmode, every fundamental pattern of coherence that forms a particle, has a phase-mirrored resonance complement. Think of it like a shadow or a perfectly inverted twin, but one that's usually invisible, unless its phase aligns perfectly with ours for detection. It's more about the internal balance of the coherence field itself, you see.
Okay. We've started to reframe the big picture, mass, gravity, symmetry. Now let's get down to the actual building blocks of matter. How does UCTE see particles themselves? Appendix C.5 says all particle families, bosons, fermions, they emerge as resonance nodes or harmonic wave mediators of the coherence tensor field. What exactly is a coherence tensor field, and what does it mean that fermions are phase-locked quantized states of coherence torsion?
Well, the coherence tensor field is the fundamental underlying field of reality. Everything else emerges from it. And when we talk about fermions, like electrons being phase-locked, quantized states of coherence torsion, imagine that underlying field isn't flat. It has these subtle, persistent twists or spirals, that's the coherence torsion. When these twists lock into very specific, stable quantized configurations, that's what we see as electrons or quarks. It's like a stable, self-sustaining knot in a vibrating rope, sort of.
Okay. So the electron isn't just a point. It's a specific stable twist or knot in this coherence field. That's a very tangible image. And this idea leads to the coherence harmonic taxonomy, or CHA.
Yes, the CHA, detailed in C.5 and C.7. It's UCTE's new classification system for particles based on their resonance tier and torsional structure. So electrons might be simple first harmonic nodes, basic twists, let's say, while muons, their heavier cousins, are second-order angular modes, more complex twists or rotations. And what's particularly insightful here is that spin, that fundamental property of particles. It's seen as a projection of internal bivector rotation. This raises a really interesting question. If spin is actually an internal geometry rotation, could that give us entirely new ways to understand, maybe even manipulate quantum entanglement, perhaps by tuning these internal rotations?
That's a fascinating thought, connecting spin directly to geometry like that. And how do composite particles, like protons and neutrons, fit into this twisted reality? Appendix C10 says they form from nested torsion chains, creating coherence knots.
That's right. Instead of just quarks being bound by gluons, UCTE describes composite particles as forming from these nested torsion chains. Imagine strands of this coherence torsion weaving together, creating complex coherence knots. These knots have intricate internal dynamics, sure, but they maintain overall external phase stability. So protons and neutrons are more like stable three-dimensional braids or coherence triangles, and torsion knots, intricately woven structures of coherence.
That's a very different image than the standard quark model of gluons flying around. And speaking of quarks, how are they held together in this framework, if not by gluons? Appendix C12 has a pretty radical take on binding forces.
It does. UCTE posits that quarks aren't held by conventional force carriers like gluons. Instead, they're embedded directly within these torsion harmonic chains. These chains are the binding mechanism. They effectively replace our current force carrier models. It even speculates that quark color, that abstract property in quantum chromodynamics, might actually be a manifestation of torsion phase chirality, a specific handedness or directionality of these coherence twists.
Wow. That's a bold reinterpretation. Okay, and what about particle decay? C.6 and C11 reinterpret it not as a random event, but as the dissolution of coherence.
Exactly. Particle decay in UCTE is the recursive unwinding of a stabilized resonance state. A particle's specific eigenmode, its unique coherent pattern, can no longer sustain its phase lock, basically, and it disintegrates into lower coherence harmonics. Think of it like a perfectly tuned instrument slowly losing its pitch and just devolving into simpler, less complex vibrations. It's not random destruction, but a systematic unspooling.
So it's a controlled fall down a ladder, maybe, rather than a sudden explosion. What are the types of decay in this view?
UCTE outlines three main modes. There's dissipative decay, which is a slow, gradual leakage of coherence, like a muon slowly transforming into an electron. Then catastrophic decay, where the phase lock completely breaks, causing the particle to essentially vanish into pure radiation, just gone. And finally, transmutative decay, which is a reconfiguration into an entirely new particle class, like when a neutron turns into a proton. What truly stands out here is that decay is reframed not as a destructive event, but as a descent along the harmonic ladder of coherence, a journey from a complex, stable state to a simpler, equally stable one.
That's a very elegant way to describe it. But where do new particles even come from in this system? C229 introduces the R bifurcation principle, lambda bifurcation.
The bifurcation principle explains the origin of fundamental particles. It states that they arise from coherent spiral splitting at very specific coherence thresholds. Imagine a rapidly spinning vortex of coherence. At certain energetic thresholds, this spiral can bifurcate split into two different forms. You get fermionic nodes, which are localized, stable, and massive, are familiar matter particles. And you get bosonic waves, which are delocalized, massless, and act as force carriers. The split depends on the spiral's internal torsion phase and its winding number. It's like a cosmic branching process, really.
So particles are born from the universe's internal spiral splitting apart. That's a very dynamic origin story. Okay, let's shift our focus a bit to the very nature of reality itself, starting with something familiar but still strange, quantum tunneling. C15, C15, and C419 completely redefine it. It's not probabilistic anymore.
That's correct. Quantum tunneling, in UCTE, isn't about a particle randomly popping up on the other side of a barrier. Instead, it's a resonant harmonic transition. Think of it as a compressed coherence wave function, finding a perfectly phase-compatible backdoor, a resonant mode on the other side of a barrier. It's a harmonic teleportation of coherence. It kind of knows exactly where it's going because it's resonating with the structure on the other side.
So it's not a jump through the wall, but more like a perfectly tuned radio wave finding its frequency on the other side. That takes the randomness out of it. And how does this coherence idea apply to something as seemingly everyday as Blackbody radiation, the heat given off by objects? C43 has a surprising take.
Instead of just thermal agitation, atoms jiggling around, UCTE reinterprets Blackbody radiation as the remission of torsionally collapsed coherence fields. Imagine a complex, braided structure of coherence that becomes unstable. As it collapses, it releases energy in a predictable way. So it's not just heat, but a signature of geometric unbinding of torsional braids. It's essentially the universe exhaling energy as complex coherence structures unwind.
That's quite a beautiful image, actually. And this theory also introduces coherence event horizons, or CEHs, in C.18. Are these like the event horizons around black holes?
Similar in concept, yeah, but profoundly different in cause. CEHs are boundaries where the propagation of coherence itself approaches zero. This leads to field lock-in and quantum causal isolation. Crucially, information simply cannot propagate beyond this critical coherence threshold. It's an information barrier created not by extreme gravity, but by the properties of the coherence field itself. Think of it as a point where the signal strength of coherence just drops to zero and nothing can get through.
That's a very abstract kind of barrier.
Yeah.
Does CPIN-18 detail different kinds of these horizons?
Yes, it outlines several. There's the CEH phase, where phase gradients just vanish. CEH torsion, where local torsion can't transmit information. CEH dark, where what UCTE calls dark coherence overwhelms the observable component. And even CEH holographic, where a field inversion creates a surface that encodes information, like a cosmic hologram boundary. This suggests that the universe itself might be, teeming with these invisible boundaries, each with its own unique story of coherence and potential collapse.
The idea of information getting locked away like that is quite thought-provoking. Let's talk about dimensionality. C.27 suggests dimensions aren't fixed, but emerge through indexed phase thresholds. What does that even mean?
This is truly fascinating. Dimensions in UCTE aren't pre-existing containers, like boxes. They emerge or become manifest at specific phase thresholds within something called the coherence spectrum. Lambda coherence spectrum. Think of the coherence spectrum as maybe a cosmic radio dial. Each dimensional layer DN only tunes in or manifests if its specific coherence threshold, EN, is met. So our familiar 3+1 dimensions are just one specific tuning of coherence.
Wow. So dimensions are like layers that unfold based on coherence, and this leads to the coherence dimensional cascade, or CDC.
Precisely. The CDC, also from C27, describes how coherence stratifies into these cascading layers. Dimensional inflation, an increase in manifested dimensions, requires a gain in coherence, like turning up the volume on that radio dial. Conversely, dimensional collapse occurs when there's a loss of coherence or decoherence, causing a dimension to effectively tune out or become inaccessible.
That's a powerful conceptual tool. And here's a truly surprising application from C28. This very same coherent spectrum also drives biological morphogenesis, how living forms develop.
It's a remarkable connection, isn't it? UCTE proposes that biological development is driven by these same phase index thresholds. Our tissues and organs, our very form, emerge through sequential threshold crossings, leading to dimensional expression. So biological form isn't just the genetic blueprint unfolding, it's a phase-index dimensional resonance. Our bodies, in this view, are complex, living expressions of the universe's dimensional layering process.
Wow. From cosmology to biology, this coherence idea seems to be absolutely everywhere. Let's delve even deeper into the unseen fabric of reality, starting with the vacuum itself. C30 tells us it's not empty, but a structured coherence reservoir, the zero-point coherence cascade. What does that even look like?
Imagine it not as empty space, but as a constantly churning, highly organized energetic substrate, a zero-point coherence cascade. And it's this cascade that spontaneously generates the entanglement weave, a literal fabric of interlaced coherent pathways. This weave doesn't just exist in spacetime, it actually pre-structures spacetime and all quantum behavior. It's like the underlying scaffolding of reality itself.
So the vacuum isn't nothing, it's this bustling foundational network. And this leads to the entangled coherence lattice, or ECL, in C.31 and C.32.
Yes. The ECL emerges directly from that zero-point cascade. Think of it as a hypercomplex, fractal coherence crystal that's interwoven throughout everything. It's a tensor lattice of entangled coherence bridges that encodes everything from phase continuity to field memory and maybe even observer-event correlation. And what's crucial is that the ECL isn't confined to our familiar 3+1 dimensions. It structures all dimensionality through something called coherence braiding, where dimensional transition points are actually topological knots within this lattice.
That's a big thought, a cosmic crystal that holds memory and even links observers to events. This brings us to vacuum tensor entanglement, or VTE, in C.35. We usually think of particles as being entangled. This says something else entirely.
Exactly. UCTE suggests entanglement doesn't exist between particles in the traditional sense we think of. Instead, it's between tensor eigenbodes of the vacuum field itself. This allows for energy-free coherence transmission. It implies that fundamental properties like mass, charge, and curvature can appear as entangled shadows of higher dimensional coherent states. The vacuum itself is entangled, and our observable reality is just a projection, a shadow play of that entanglement.
So the appearance of reality is truly a holographic resonance of the vacuum.
Yeah.
As C.36 states, that's genuinely mind-bending to consider. If that's the case, where does memory fit into all of this? C.31 has a very novel definition.
In UCTE, memory isn't just a stored file in a brain or on a hard drive. It's understood as a field architectural structure. The ECL itself is the memory structure. This allows for what UCTE calls non-local memory and phase continuity across vast distances or maybe even different dimensional layers.
So the universe itself has a built-in memory system. How does that work?
Well, the memory field architecture within the ECL seems to have distinct layers. These layers maintain phase alignment, they store relative spin and curvature information, preserve spectral entanglement, and even modulate selective memory encoding. When you recall something, it's not like pulling a file from a cabinet. It's described as a phase-aligned re-entry into the original resonance mode. You're effectively retuning yourself to the coherent pattern of the original experience, which is etched into the ECL.
That's a profound way to think about how our own minds might work, tied directly to the fabric of reality itself. Okay, now let's quickly touch on some of the more advanced structures that Lillian details. C.23 introduces quantum braid bundles, or QBBs. What are these things?
QBDs are fascinating. They're described as topological phase structures. Think of them as complex, braided conduits that carry coherence across different layered torsion domains. They form stable composite structures through multi-torsion phase crossing, and UCTE suggests they could be responsible for long-lived coherence states, acting as torsion-driven entanglement channels. They're like super stable interdimensional cables for coherence, maybe.
Interdimensional cables. Wow. And what about dimensional torsion lattices, DTLs, from C24?
Right. DTLs are conceptualized as structured coherence environments. Imagine discrete torsional nodes forming a lattice. This structure gives rise to phase crystal resonators, PCRs, which are stable standing coherence waves. The theory suggests particles might appear as trapped PCRs within these DTLs, which could explain quantized mass spectra in a new way.
Okay, and then coherence tensor crystals, CTCs, in C26.
CTCs are stable, recursively symmetric resonance lattices. They form from the interference nodes of coherence tensors. They create these multi-eigenmode shells. Think something akin to atomic orbitals, but potentially for any force field, not just electromagnetism.
Right, complex structures. And briefly, coherence permittivity wells, CPWs, and tensorial resonance funnels, TRFs, from C.51. Sounds like cosmic plumbing.
Sort of. They're conceptualized as hyperdimensional energy structures. Imagine them as localized energetic drains or funnels within the coherence field. They act as minima in the coherence gradient field, effectively guiding coherence into structured emergence zones. They're like cosmic moles that shape raw coherence into quantized fields and localized particle states. They sculpt reality at a fundamental level.
Okay, shaping tools. And finally, there are transdimensional tensor bridges, or TTBs, and recursive coherence bridges, or RCBs, from C.54 and C.56. These sound like literal bridges between dimensions.
They are, conceptually. These are described as structured conduits spanning across coherence-separated dimensional layers. They allow coherence to cross dimensional threshold without decohering or falling apart. They're resonant topological corridors for quantum entities or even entire coherent structures to tunnel or traverse between dimensions. UCTE even introduces quantum traversal metrics based on how well coherence integrity is maintained during these crossings.
So what does this all mean when we try to bring it together? Lillian offers a unified collapse equation in CNS 3.4, a second version apparently.
The unified collapse equation is presented as the master rule, the thing that governs all tensor coherence transitions. It shows how high-dimensional entangled coherence spinors, these complex rotational entities, rotate through torsion gradients, define resonant shell structures, and ultimately project into stable particles, fields, or even vacuum condensates. It's an attempt at a mathematical framework that ties everything together, from the subatomic to the cosmic scale.
And the implications of all this, particularly from C42, seem immense. As the coherence field approaches its entangled maximum, a boundary of locality emerges.
Yes. At this boundary of locality, our usual understanding of local causal dynamics, cause and effect as we know it, starts to dissolve into non-local phase-locked interference structures. Here, space-time ceases to be the primary descriptor of reality. Instead, field resonance topology becomes dominant. It means that at the most fundamental level, information isn't confined to a specific location. It dissolves into the grand, interconnected web of coherence entanglement. Locality breaks down.
So what does all this mean for you, listening? It means reality isn't just what you see and feel. It's potentially this symphony of invisible coherence, weaving itself into existence through these incredible, intricate mechanisms detailed in the addenda. From the tiny twist that gives a particle mass to the unseen bridges between dimensions, coherence seems to be the thread that connects everything in this theory.
We've just taken a really deep dive into how everything, mass, gravity, particle decay, entanglement, even the fabric of dimensionality and possibly consciousness, can potentially be understood as expressions of a grand structured coherence field. It's a truly unified picture being proposed here.
Think about this final thought. If mass is memory of coherence held, phase-preserved, structure endured, what hidden memories are woven into the very fabric of your own existence, just waiting for you, maybe, to uncover?
We definitely encourage you to explore the UCTE further if this has sparked your interest. These concepts hint at incredible potential applications, maybe in quantum computing, advanced propulsion, or even entirely new ways of understanding biological intelligence. There's clearly so much more to potentially discover about the nature of reality through this kind of lens.
Thank you for joining us on this incredible deep dive. Until next time, keep exploring, keep questioning, and definitely keep an open mind to the universe's deepest secrets.